Good day, everyone. So today we will be discussing the fourth topic. Uh, no, the third topic for information management, which is the database system architecture. So this topic is divided into two parts, so that at the end of each parts you will have your assessment quiz as to how much you have comprehended with the discussion. So let's start. So the objectives of this topic is to mainly for you students to differentiate centralized and client server systems. You should be able to explain what are these server systems, explain parallel systems, and then explain also the distributed systems. Then you should also be able to differentiate network type. So let's start with what do you call this one, discussing what's the computer architecture. So when you say computer architecture, it is how your system is being built, how it runs, how one part is connected to the other, how one process can affect another process, or how each part or how each hardware are connected with each other, and then who are involved, or what are the processes involved so that these hardwares will work. Okay, so when you say how also in we have here the definition of the architecture of your database system, which is greatly influenced by your computer systems. So when you say greatly influenced by the computer system, the database performance depends on the computer system that you are currently running with. So if you have a high end or a fast computer systems, then basically it follows that your database system will also be fast or efficient in processing queries. So when you say computer system, you have here you are what you call this when you are looking into the different aspects as to the networking, parallelism, and distribution. So when you say networking, it's how computers are interconnected with another computer. Parallel processing, so that is what are these processes involved, or that can what do you call this one, that can run at the same time. Distributing data across the data across sites. So distributing data across sites, that is what they call this one, how uh, how distributed database works. So let's go first with centralized and or centralized or versus or against client server architecture. So when you say centralized system in general, you have this one one computer, or what do you call this one computer, or one server, which houses all the application uh all the application programs as well as the database. And this centralized systems have what we call workstations. So these workstations will access the database through a network in into the centralized server. So you have here one server, then workstations are connected to that particular server. So the workstations resources are coming from the centralized server. So the database is saved in the centralized server. All the processes is saved in the centralized server. Also, all data are being saved in the centralized server. Okay. So this is how a centralized computer system looks like. So as you can see, you have a network in which you are connected, naka-connecta na dito ang disk, pati ang imuhang CPU naka-connect, and then the memory shared siya sa tanan nga workstations. So ang naa ra gyud ni user is the workstation katong naa kay monitor, naa kay keyboard and the mouse. So every resources are coming from one server. Apil lang dira ang memory, CPU, and the storage spaces. So naatanan sa centralized server. Now, when although most general purpose computers, they have coarse granularity parallelism. So with only a few processors, but about two or four, all and then all sharing the main memory. So in contrast with fine granularity parallelism, which have a large number of processors and database systems running on such machines, attempts to parallelize single tasks submitted by users. So let's now proceed with client server systems. So in client server systems, you have set of clients who will access the what they call this one, server. So it's a personal computer. When the personal computers became faster in terms of processing task, which is a more powerful and cheaper, there was a shift away from centralized system architecture into client server systems. So in client server systems, you have basically a server which holds the application and the database. However, in the client also in their end they can they have their own what do you call this one? They have their own CPU or central processing unit, and they have their own storage spaces, and they have their own memory or main memory. Okay, so the the centralized systems today act as the server systems in client, which will satisfy the request generated by the client systems. So functionality wise, it provides the database systems. So the server provides the database systems can be broadly divided into two parts, the front end and the back end. So systems nowadays na natay front end. Si front end dito ma-access kang client. Si back end dito reside sa server. So the backend manages access structures, query evaluation, and optimization. And the front end of a database system consists of the different tools such as SQL SQL interfaces, forms, report generation tools, and etc. So it is the client server system. It's the interface between the front end and the back end is running through the SQL or through an application program. So this is how a client server architecture looks like. You have your server connected through a network are the clients. And the clients sa client naka-reside ang front end. Dito ma-access ang front end. To ma-access yung front end. So sa front end, na dito tong user interface nimo where you can generate report, where you can issue queries, na dito sa front end. And then the database itself is residing or the backend is residing in the server. Katulad lang sa mga procedures, mga triggers, na siya sa server tanan. So all the requests will still be coming from the client and it will be processed in the server. And whatever is the response of the server to each client request, then it will be displayed to the certain client who requested that particular uh, task. So in every client, they have their own CPU, they have their own memory and they have their own storage spaces. Unlike in centralized system, the CPU, the memory, and the what do you call this one, the storage disks are being handled alone by the server, and the server also handles both the front end and the back end. So this is how we usually divide the parts where what can a client see and what does the server contains. So front end, you have here your report generating tools, your user interface, and then you have here your SQL interface, or we call it the RDBMS, the relational or the DBMS, the database management system, and you have here your SQL engine in your backend. So when you say client server systems, it deals with large number of users that usually adopts three-tier architecture. So you have the first tier is your client, the second tier is your application server, and you have your database as the third tier. So let's try to check this one by one. So some transaction processing systems provide a transactional remote procedure call interface to connect clients with a server. And these calls appear like ordinary procedure calls to the programmer, but all the remote procedure calls from a client are enclosed in a single transaction at the server end. Thus, if the transaction aborts, the server can undo the effects of the individual remote procedure calls. So in so that's how client server architecture is. Now let's go to server systems architecture. So it can be broadly categorized as transaction and data servers. So when you say transaction servers, it is also called the query systems, or transaction server systems are also called query systems. So it provides the interface to the client in which they can send request, send request to perform, and that request will result into a response, and a response can be seen by the or through the transaction server. Now, on the other part, we have here the data server system. So this allows clients to interact with the servers by making requests to read or update data in units, with such as files or pages. Then they provide indexing facilities for data and provide transaction facilities so that data can never left in an inconsistent state of a client machine, or if a client machine or process fails. So usually when you say transaction server system, it is it consists of multiple processes accessing data in shared memory. So the processes that form part of the database system includes the server processes and the log manager processes. So for transaction server systems, you have your database writer, which includes log writer and checkpoint processes. And the other one is your process monitor process. So you have your, when you say database writer processes, it will basically be responsible for the log writer processes, and checkpoint process, and the other hand is process monitor. So in data server, so that's for transaction. Now let's go to the other category of server system, which is the data server systems. So these are used in local area networks, which There is a high speed connection between clients and servers, and the client machines are comparable in processing power. The serve machine and the tasks to be executed are computation intensive. So when you say data server systems, you have here the issues arising in this type of architecture. Number one, page shipping versus item shipping, adaptive lock granularity, data caching, and lock caching. So we also have here another type of server, which is what we call the cloud-based servers, which is actually the trend today, presently. So we I think we're familiar with Google Drive. So Google Drive is an example of an application that resides inside a cloud server. So these servers are usually owned by a uh third party company which provides server services. But there is an increasing trend for service providers that to rely at least in part upon servers that are owned by third party. So another model for using third party servers is called the cloud computing, in which service provider runs its own software, but it runs on computers provided by another company. So when you say cloud computing or cloud-based servers, the what you gonna the servers are being owned by another company in which they rent out these servers to different companies or organizations for them to have their own instead of in to have their own servers. So instead of buying the physical servers on their own, they will rent it from this cloud providers. And in the what they call cloud in the cloud providers, they they have their we have their what you call this one classification of what are the services that you are going to what they call avail from these third party providers. Number one is uh service infrastructure as a service. So meaning as if you are going to configure your own servers, kautanan. And then you choose how do you configure your servers, what are the softwares that you will what they call this one uh install and whatsoever. Then we also have their platform as a service. So when you rent, you have this platform as a service, and then you are just giving hosting services. Then you have their software as a service, SaaS. So you are just going to rent the specific softwares installed or present in that particular cloud provider. You can use that in your own company. So kung kung the company has its own IT specialists that can really manage infrastructures, then most companies, kaning mga big companies, what they call this one, go for infrastructure as a service because they can customize it uh, according to their needs. So the nowadays the trend is cloud. So there is no physical less na ang physical nga what they call this one servers housed in a company in a company. Instead they are renting out because when you rent out or when you subscribe a cloud service, what you are going to be concerned with is the maintenance of the subscription that you have. So your what you call this one, what you have to look into is making sure that you are paying on time. Number two is that making sure that you have configured it correctly so that it will not cause any adverse effect in your company. What else? When in terms of technical personnel, because the technical maintenance of the cloud uh service that you have what they call this one uh subscribe. When you say hardware maintenance, wala na kaana. Dito na na siya sa cloud service provider. So the hardware maintenance will not be your call. So in case that there will be a hardware failure, you as the subscriber will not be the one responsible to what do you call this one to do maintenance repairs for the hardware failure. It's the cloud service provider. So that's why cloud what do you call it, cloud-based server systems nowadays are being what do you call this one trending na siya. And then another thing is that the good thing about having these cloud service providers, you can access your data anytime, anywhere. So, di ba, like for example, Google, you can access your Google Drive anytime, anywhere. There is no such limit that restricted ra ka sa isa ka local area network or within the network of your company in order for you to access your resources. So that's the good thing of cloud-based servers. All right. So when you are going to subscribe to a cloud service, then you are actually interacting with the server through a virtual machine. So it is where you can configure your server, you can have maintenance in your softwares that you have uploaded and that you have subscribed from the service provider. So that's for server systems. Now let's go to parallel systems. So when you say parallel systems, it improves processing when it comes to input output speeds by multiple processors and this in parallel. Meaning you have instead of one processor naka-queue ang tanan nga task, you have multiple processors and the task will be distributed to different processors and can be executed at the same time or simultaneously. So the driving force behind parallel database systems is the demand of applications that have to be that have to query extremely large databases. And then a coarse grain parallel machine consists of a small number of powerful processors, and a massive parallel or fine grain parallel machine uses thousands of smaller processors. So in parallel systems, you have two main performance measures of your database system: the throughput and the response time. Oops, I have here what they call this one. So I have deleted here mm, the definition for response times. But anyways, let's just continue. When you say throughput, it refers to the number of tasks that can be completed completed in a given time interval. So meaning if you have 5 minutes, how many tasks or queries or requests from the clients or from the users can be completed. So that's throughput. Example, in 5 minutes, you have completed about 200 tasks or 200 requests. So 200 is your throughput. Okay. On the other hand, when you say response time, it is the amount of time it takes to process a single task from the time that the user submitted it for the request. So take note how when you say response time, it is the amount of time that yeah, amount of time it takes to complete one single task from the time of its submission. Okay, so I'll just repeat. When you say throughput, the number of tasks that can be completed in a given time frame or a given time interval. That's throughput. When you say response time, the amount of time that is given or the amount of time it takes to complete a single task, meaning how much time did task number one needed for it to be completed? Is it 10 seconds? Is it 5 seconds? So you are going to measure it how long a single task is being processed. So that's for the response time. Okay. So there are two important issues in studying parallelisms. So these are the speed up and the scale up. So when you say speed up, that is running a given task in less time by increasing the degree of parallelism. So meaning, uh, many processors will process the same task so that it can be finished or it can be completed in a shorter span of time. But on the other hand, when you say scale up, these are handling larger tasks by increasing the degree of parallelism. So, meaning accommodating a number of tasks or of requests from different user and also increase the uh, parallelism or what we call the 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 processors who are or who is processing those tasks. So speed up, that is given a single task, in order for that single task to be completed in a shorter span of time, then all other processors or from one processor it will be increased to two or more processors so that that task can be finished or completed in a less period of time. So that's for one task for speed up. But when you say scale up, you increase the number of tasks, and and when increasing the number of tasks, you also increase the number of processors to process those tasks. So that's how speed up and scale up differs. So to demonstrate linear speed up, if if the speed up of is n, when the larger system has n times the resources of the smaller system. And if the speed up is less than n, the system is said to demonstrate sublinear speed up. So there are scale up. So scale up relates to the ability to process larger tasks in the same amount of time by providing more resources. So there are two kinds of scale up. We have the batch and the transaction scale up. So when you say batch scale up, the size of the database increases and the tasks are large jobs whose runtime depends on the size of the database. But when you say transaction scale up, the rate at which transactions are submitted to the database increases and the size of the database increases proportionally to the transaction rate. And scale up is usually the more important metric for measuring efficiency of parallel systems. And the goal of parallelism in database is usually to make sure that database system can continue to perform at an acceptable speed given uh, a certain amount of transaction, or as the transaction increases or as the size of your database increases. So that's for parallel systems. So parallel systems consist of different components. You have your processors, memory, and disks that can communicate with each other via interconnection network. So there are three types of common networks in parallel system: bus, mesh, and hypercube. So when you say bus, all the system components can send data on and receive the data from a single communication line. So that's bus. When you say mesh, the components are nodes in a grid, and each component connects to all its adjacent components in the grid. Whereas hypercube, the components are numbered in binary, and a component is connected to another if the binary representations of their numbers differ in exactly one bit. So you have your parallel systems architecture, you have your shared memory, shared disks, or you have shared nothing or hierarchical. So in parallel system architectures, number one type is shared memory. So all the processors share a common memory. So nakaisa ka memory for all the processors in your parallel systems. For the shared disk, all the processors share a common set of disks, and it is sometimes called clusters. For shared nothing, for shared nothing, the processors share neither a common memory nor common disk. And hierarchical, this model is a hybrid of the preceding three architectures. Now let's go to distributed database systems. So when you say distributed database systems, it is a day or database are being stored in several computers located in different locations or in different geographical locations. So the computers in distributed system communicate with each other through a network, given that you have a high speed internet. So basically examples of distributed systems, Facebook, it's using distributed system. So they have different databases located all around the world, and then uh, uh, example, Facebook on Philippines can still access a server or the same data in Facebook US or in Facebook Singapore. So that's an example of distributed database system. So usually mo in centralized system, you have one database located in one computer, and all other clients will access it. All other clients all over the world will access it. So ang example anong centralized system na to is si Prisms. So si Prisms na isa rang server, tanan nga users mo access at the same server, the same location. On the other hand, in contrary to that, you have your distributed database system. You have multiple copies of databases of the same database located in strategic geographical locations. When you say strategic, it's what you call it, it's the nearest to its region, to a specific region. Okay, so exact copy of the database located in different strategic regions or strategic locations, and those nearest to one database location dito na ma-store ang iyahang data in that particular location. However, that data can also be accessed by other locations. So seamless ra siya, as if you have a single database, but in reality, daghan siya. And they are interconnected with a high-speed network. So usually mo na siyang ginagamit ni Facebook, ni Google, ni Instagram, even kaning mga dagko na nga systems or mga companies like the Nestle, the Coca-Cola mo na ilang ginagamit distributed systems. That is for what do you call this one? Distributing the database load, and then for faster database performance. So each location in a distributed database system is called sites or nodes. And these sites or nodes are administered separately by different administrators. So when you have a distributed system, you have what we call local transaction and global transaction. When you say local transaction, that particular transaction is located in one database location. But when you say global transaction, you are going to to execute a transaction from one database location across another database location or another database node. So from site 1 to site 2, if you perform a transaction that involves data from site 1 and site 2, that's global transaction. But when you say you are going to request for a transaction which involves data within one location or within just site 1, then you have there the local transaction. So there are several reasons why distributed systems are being used nowadays. Number one, sharing of data, autonomy, and availability. So even though you have what do you call this one, different locations for your database, you can still share data. Meaning, site number one can access the data in site number two. Site number two can access data in site number one. Site number two can access data in site number five, and so on and so forth. And that's a good thing for that. Then autonomy. So the primary advantage for sharing data by means of distribution is that each site is able to retain the degree of control that they have in their local data or local in site one. And availability. When you say availability, since you have multiple copies of the same database located in different geographical location, in cases that site one will fail, still users from site 1 can access the same database located in different sites like site 2 or site 3. So, minimal ang downtime. If not prevented at all, at least minimal. Because you have multiple copies of different uh, databases in different sites. So the problem is just that you have implementation issues. So you have to make sure that all transaction is in a distributed system is in atomic state. So unsa tong transaction dapat makuan siya uh, ma-execute siya as one unit for it to be atomic. So natay two-phase commit protocol. So this two-phase commit protocol, this will ensure that such situations cannot arise. So concurrency on control, of course, because you have multiple, what do you call this one, multiple users accessing your database at the same time. And then now let's go to network types. So basically you have now an idea of what are these network types since you are already done with your networking or currently studying with your networking. So when you say LAN or local area network, you are the connection is local within a building or the same geographic location. So example, ang ang isa ka building, na-access ra nimo ang isa ka website if naa ka anang sulod ni USTP. Kung magawas ka ni USTP, dili nimo siya mo-access. So, ang tawag ana nga network is local area network. Now, we also have what we call the WAN or the wide area network. So, mo na ni siyang implementation ni internet. That's the best example of wide area network. So, network number one can access network number two. Nakakuan na siya, naka-interleave na siya nga network. Okay? So that's all for the first part of database architecture. So at the end of this part, let's have a quiz or an assessment quiz to check how far you have comprehended with the discussion.